In this video, we are going to recap our strategies for optimization questions. So let's begin by letting f be the objective multivariable function. And remember that objective is just a word that we use to refer to what we want to either maximize or minimize. So there are two types of optimization problems, max-min problems that we've looked at. The first case was when we just had a function given and no constraint. So this was section 8.3. And our strategy for dealing with these was we took our partial derivatives and we then find critical points. We find critical points. And then after we have those, then we test the critical points with the second derivative test to see if they give us a max or a min or a saddle point to get a conclusion. Okay, and then the second case is, what if I have a constraint along with my objective equation? Okay, and the convention we've used for writing the constraint is we call it g. So what if I have a function g of some variables x comma y? Maybe there's more variables. And when we do Lagrange, and I'll talk about Lagrange a little bit, we get this so that this whole thing equals 0. But there's some constraint equation. And we learned two ways for dealing with max-min problems with a constraint. The first was to do it by substitution. And the second way to do it was using Lagrange multipliers. All right, so there are two comments that I want to make about things to look for that can help us decide, which way might be a bit better. So the first is when it's hard/impossible to isolate a variable in our constraint so that I can then substitute in. Well, if that's hard or impossible, then you want to use Lagrange. On the flip side, when it's easy to isolate, then we can use either method. We can use either Lagrange or substitution. All right, and these max-min problems with a constraint we talked about in section 8.4.